Well, what are the chances? It's Mr. Thompson here with a math video lesson on probability. You probably have an idea of what probability is. It's the likelihood, the chances that certain events are going to happen. This is the first of a few videos that we'll be talking about probability, diving into the deep end and how to do calculations and stuff. So a bit of terminology and some real basic intro calculations and stuff that we're doing today. So sample spaces and events. Then we'll talk about calculating probability, how to do it, and do some examples. And then we'll talk about complementary events. So that's what's on more detailed table of contents in the description below. And you should be able to scrub along the timeline to see the chapters in this YouTube video. So with that said, let's get into it. So sample spaces. What are sample spaces? Sample spaces are all the possible outcomes of an experiment or a trial. So basically, something's going on. It's all the different things that could possibly happen, right? That's how I describe it in everyday language. It's just the different things that could happen, right? What are the outcomes? What are the events that could occur, right? There is a symbol that we use to represent sample spaces. It's called epsilon. It's a Greek letter. It kind of looks like a backwards 3, but it's the size of a lowercase letter. And we use it to represent sample spaces. So when we're asked to find a sample space, we need to use that symbol. And so, for example, we might look at a coin flip. What are the possible outcomes? So we do our epsilon, and we also use these curly braces to put the list of all the different outcomes that could happen inside of. So with a coin flip, it's heads or tails. So we can represent that with H and T. We could write out the words if we wanted to, but keep it simple if you like. Okay, another example, a 6-sided die, right? Rolling dice, dice and coin flips, as well as maybe playing cards. These are the kinds of things we'll see a lot of. So we put our epsilon and our curly braces, and the outcomes are 1, 2, 3, 4, 5, or 6, right? So there's a few quick examples on sample spaces. Events. An event is a subset of the sample space. Okay, so what does that mean? Well, a subset is any combination of things that could happen, right? So any different groups of outcomes. So each individual outcome is an event. You could even include all the outcomes could be events, or certain combinations and groups of events. So let's look at what that looks like. When rolling a 6-sided die, here's some different examples. So like I said, rolling a 3, that's an event, right? That's one possible outcome. Rolling an odd number. So there's different odd numbers that we could see, right? 1, 3, and 5. That subset, that list of 1, 3, and 5, that is an event. So rolling an odd number is an event that has 3 outcomes in it, right? Rolling a number less than 4. So less than 4 would be 1, 2, or 3. Again, 3 outcomes in this event. There's all kinds of different combinations, and there's a whole mathematics about how to find the number of combinations and what the different combinations are. We'll save that for later. But this is the general idea of events. All right. A few notes on sample spaces and events. They can be discrete. Okay. Discrete is where there's a proper distinction between the events and the outcomes and things like that. So things like numbers of people, you can't have like 1.5 people. You can have 1 or 2 or 3. And nowhere in between, right? They don't sort of overlap or run together, right? Colors, when we define colors, they are distinct, unique colors. Categories like top, bottom, left, right, things like that. Hot, cold, although temperature is continuous, but stuff. So discrete are separate, non-overlapping, and no gradient in between them, things like that. Whereas continuous runs together, and there can be very little distinction between two different continuous values. So like lengths, you could have something that's a certain length, but what if it's just a tiny bit shorter, right? There's no distinction between how much shorter it can be. It could be a teeny tiny bit shorter. Or speeds, like you might be going 80 k's per hour on the highway, or you might be going 80.5 k's per hour on the highway, or 80.55 and things like that, right? So there's sort of infinite intervals in between that you could be that you could have, right? So discrete and continuous, as well as they can be finite, right? So with a defined list, a complete list of outcomes like heads or tails or numbers on a dice, right? 1, 2, 3, 4, 5, and 6, and so on, right? Or primary colors, there's really only 3, right? So these are finite. We can list every single possible outcome, or we can have sample spaces and events with infinite outcomes, right? So things that you can't sort of make a list of every single thing that can happen. You might, the number of times a dog barks, you can represent it as like 1, 2, or 3, ... because, there's no sort of maximum amount that a dog can bark, right? Or names, right? There's no absolute set of list of names that will ever be or could be, right? What are the chances of a baby having a certain name? Well, we don't really know. We don't have like a list of exact names that people could use. So the sample space there is infinite, okay? All right. Calculating probabilities, but before we can calculate them, we need some notation here. So to represent the probability of an event, we use the letters PR, okay? And then we put the event in brackets. So that looks like this, PR, brackets, and A. So this means the probability that event A will happen, okay? Now, I haven't defined what A is, but in a in a problem or in a scenario, it would say let event A be such and such, right? And we'll see that in just a second. You can put actual words or letters and things like that which represent real things. So probability of heads or probability of H, right, would mean the probability that a coin lands heads up, right? Okay, let's look at the actual calculations. So to find the probability that something is going to happen, to calculate it, we divide the number of outcomes that represent the event, right, in the event, the number of outcomes in the event, by the total possible outcomes in the sample space, right? So the sample space has to be finite. We can't divide by an infinite number or a number that we, can't calculate or find, right? So, so we write that out as a fraction. So probability of A is the number of outcomes in A divided by the total number of outcomes in the number of outcomes possible in the sample space. We can write that with more notation here with the letter N in brackets. So that would mean the number in A over the number in the sample space. We use that epsilon, right? Couple of notes on this. The probability, if we take all of the outcomes, all of the different outcomes, each individual outcome, and we find the probability of each one, and we add them up, that must come to a total of 1, right? Or 100%, right? The chances of some outcome happening, if we roll a dice, the chances of either a 1, 2, 3, 4, 5, or 6 has to be 100% because that's all of the outcomes. And the other thing is the probability of an event can never be negative, right? So just remember that. All right, and let's look at some examples, okay? So if we're rolling a 6-sided die, we're going to say let A, here's how we define an event, let A be rolling an odd number, right? So we want to find probability of A, right? So it's a 6-sided die, and we remember that the probability of A is the number in A over the number in the number of events, outcomes that is in the sample space. So probability of A is going to be a fraction, right? And with rolling an odd number, that would be 1, 3, or 5. There are 3 outcomes in A. And in the sample space, there are 6, right? So 3 over 6, we can simplify that to 1/2. And if you want to put 50% or whatever, that's fine. But that's the answer. Another example, let event B be rolling a number less than 3. So find the probability of B, right? So very similar. In the event, there are 2 outcomes, right? 1 or 2. Those are the only numbers less than 3, right? So the probability of B is 2 over 6, our sample space again. And again, we simplify 1/3, or you might round it to 33% or something along those lines, okay? The maths can obviously get a little bit harder. The fractions can become more difficult to simplify, but this is really the basics of it. Okay, last topic here for this video, complementary events. When 2 events have no outcomes in common and together make up the entire sample space. So if you list out event A and event B, they have nothing in common, but they together make up the entire sample space. So rolling an odd number and rolling an even number. There's no odd numbers that are also even, so they don't overlap. They have none in common. And odd numbers and even numbers on a dice, they make up the entire sample space. 1, 2, 3, 4, 5, 6, right? Like so, right? 1, 3, 5, 2, 4, 6, right? Those are our complementary events. Another way that complementary events happen, you might say rolling a 6 and rolling anything other than a 6, right? It's kind of obvious, but that's the sort of thing we sometimes see with complementary events. Couple of notation notes for complementary events. They're represented with an apostrophe. So the complement of A is the event A prime, or A tick. I know there's different ways of sort of pronouncing that, but that's how it always looks. Okay. So if we said the 1, 3, and 5 are event A, then 2, 4, and 6 would be A prime with a little apostrophe up there, the tick, or whatever we call it. And one last note, the probability of a complementary event, like the complement of A, as we might say, is equal to 1 minus the probability of, where's my in brackets? Let's put that on there. There we go. The probability of a complement is equal to 1 take away the probability of the event that the complement is the complement of, right? All right, hope that helps. More videos to come on probability. See you next time.